All right, greetings everyone. Welcome to the second part of the video for section 8.2. Continuing on with some studying of polar coordinates, and as we showed in the last video, there are some relationships between polar coordinates and Cartesian coordinates, and kind of how they're plotted. So here we're going to look at converting between the two sets of coordinates. So in order to do that, we have a set of formulas here that hopefully look kind of familiar. In particular, these ones here, right? We've seen for most of the quarter this idea that cosine of an angle is equal to x over the length of the radius, and sine is equal to y over the length of the radius. For that matter, I think we've also talked about tangent being y over x, and the Pythagorean theorem type identity here that x squared plus y squared equals r squared. The other two might look a little less familiar. Hopefully you can also see how they come from these other ones, right? So if we have, say, cosine of theta equals x over r. If I solve for x by multiplying by r on both sides, what we end up with is x equals r cosine theta, which is what we see here. Okay, so these formulas are all interrelated. And as I mentioned, we can use them to convert between polar coordinates and Cartesian coordinates. Now, if we're going from polar to Cartesian, that means that we've been given an r and a theta value, and we have to convert them to x's and y's. And hopefully you would see that in order to do that, we could use these sets of formulas here, right? So x equals r cosine theta, y equals r sine theta. Okay, so that's, we plug in the values for r and theta, it gives us our x and a y. On the flip side, if we need to go from Cartesian to polar, so from xy values to our theta values, these other sets of equations can be useful. So in particular, you hopefully see that we can use x and y to find the value for r directly here. And then to find the value for theta, we actually kind of have some options. We can use any of these three formulas over here. Okay. All right, so let's look at doing this now. And I'm going to start by doing a Cartesian to polar conversion. So here we're given the Cartesian coordinates -3, -4. And recall that because those are Cartesian coordinates, oh my goodness, here we go. Because those are Cartesian coordinates, we know that they are x comma y values. And so we need to convert them into polar, which means we need to end up with an r comma theta point, okay? All right, so as I mentioned, we can start this process by finding the value for r using that equation x squared plus y squared equals r squared. If we plug in our values for x and y there, we would have -3 squared plus -4 squared equals r squared. -3 squared is 9, -4 squared is 16 equals r squared. Can go to the next step then. 9 plus 16 gives us 25 equals r squared. And then we can solve for r by taking the square root. And so in this case, we would get r equals +5. Now I know often when we're solving using square roots, we use plus or minus to show the two different answers. But in this case, because we're looking for the value for r's, and we've seen the value of r can be negative, but generally we're going to use the positive ones. So in this case, we know that our value for r will be +5 now, and we need to find the value for theta. Now, in order to do that, as I mentioned on the previous slide, we have several options for how to find theta, because we have formulas for cosine of theta, sine of theta, and tangent of theta. In our case, I'm going to use tangent of theta since we're given an x and a y value. So we know tangent of theta equals x over y. which in this case our x value is -3, our y value is negative, and oh my goodness, Cody, that is wrong. It should be y over x. I apologize. So this would be -4 over -3, which would give us +4/3. So we have tangent of theta equals that. And then we can use inverse tangent of 4/3 to help us find theta. And if we do that and plug it into the calculator, we end up with 0.9273. And if we think about that angle, so if we draw a coordinate grid here and think about quadrants, we took the arctan, or the inverse tan of a positive number. We know inverse tan can only give us answers in the first or the fourth quadrants. So therefore, this 0.9273 has to be where tangent is positive, which would be in the first quadrant. However, actually, let me label that. Think about where the point -3, -4 is. Well, that means go to the left 3 units on the horizontal axis and then down 4 units on the vertical axis, which then means that our point here is actually down in the third quadrant, which hopefully makes sense because that's also a place where tangent is positive. So we need to use this angle, this 0.9273, to help us find the angle here in the third quadrant. And so we can do that by using 0.9273 as our reference angle. So the angle right here, 0.9273. And because we're going beyond pi to get that value, we'll do pi plus the reference angle, which is 0.9273. And adding those two together gives us 4.0689. Okay. So in this case, our point in polar coordinates, our r comma theta, would be 5 comma 4.0689. All right. Okay, let's look at the second problem then. So now we're given the polar point 3 comma 11 pi over 6, which again, we recall that this is, because this is a polar point, we know this is an r comma theta value. And when we have r and theta, the process for finding the x and y coordinates in Cartesian coordinates, which is what we're looking for here, is actually much more straightforward because we just have x equals r cosine theta, and oh my goodness, that was terrible. Let me try that again. R cosine theta, and y equals r sine theta. Okay, so we plug in the information we have. So we'll do 3 times cosine of 11 pi over 6. And sorry about that. And then we'll do 3 times sine of 11 pi over 6. When we do that, think about this is on the unit circle. 11 pi over 6 is in the fourth quadrant, so cosine is positive there. So this would be positive √3 over 2. And then 3 times sine of 11 pi over 6. Well, in the fourth quadrant, sine is negative, so we'll have -1/2. And on both of these, we can make the 3 a 3 over 1 and do our multiplying straight across of our fractions. So end up with 3 √3 over 2 and -3/2 as our two answers. So our Cartesian coordinate point there would be 3 √3 over 2, but not with that crazy thing. There you go. And -3/2. And that's our answer. All right, that's it for now. Thank you for watching.